Welcome back to Civil Engineers YouTube channel. In this short video lecture, I will guide you for how to find minimum depth of footing. So guys, you can see footing. We have different types of footing, but in this video, I am guiding you for individual footing. Guys, you can see this is individual footing. Inside this, we have RCC column. So what should be the depth of footing? Like this, guys, you can see this is column and this is depth of footing. Okay, this is ground level. So what should be the depth of this footing? Depth. So this is the video. So guys, you can see here, first of all, it's very important to calculate the minimum depth of footing or how to calculate depth of foundation or footing. Remember guys, depth evaluation can be done using Rankin's formula. It is the most widely used equation to calculate the depth of foundation. Now what is Rankin's formula? So the following equation is the Rankin's formula. This is the Rankin's formula. D is equal P divided by Y into sine theta 1 minus sine theta divided by 1 plus sine theta and all square. Guys, you can see this is square. So where D means depth of footing, P mean applied pressure or allowable bearing capacity of the soil. Bearing capacity of the soil. Okay. So applied pressure or allowable bearing capacity of the soil. This is P. Where Y is the density of soil. Different types of soil has their different density of soil. Okay. So now this theta angle, this is angle of repose. What is angle of repose? Guys, you can see here the soil. Guys, you can see this is a soil. Okay. And this is the ground level. This one, ground level. So angle of repose, guys, you can see. So this is soil. So when it make an angle, this angle or this side, so this angle is called, or you can say this one, this angle is called angle of repose. Okay. So it's depend on the soil condition. Next, what is P? P is the applied pressure or the following allowable bearing capacity. When you know the applied pressure by the foundation on the soil, we may use it for the calculation for the footing depth. Otherwise, allowable bearing capacity could be used as we anywhere do not allow to exceed the limit stage pressure than the allowable bearing capacity. So next, guys, you can see servibility. This is also very important. Okay, so angle of repose. Okay, these are okay. So steepest angle at which is sloping surface format or loose material is stable. Guys, you can see as I discussed here. Next, if you see guys here, this one. Okay, so sorry for that. Next, guys, you can see this depend on the soil we used. Okay, because different types of soil has their different angle of repose. Now let me calculate how to calculate minimum depth. So this is very easy. As you can see, this is a data. Allowable bearing capacity is suppose 150 kilonewton per meter square, maybe 100 kilonewton per meter square. Okay, it's depend on the pressure. Okay, so the density of the soil is suppose 18 kilonewton per meter square. Remember guys, the structure load of the building should be less than the bearing capacity of soil. It means the bearing capacity of soil should be maximum on the applied load, or the applied load is a structure load or self weight of the load. So therefore the density of the soil is 18 kilonewton per meter cube. So this is its density. If you see guys, this is allowable bearing capacity. Bearing capacity, this is a pressure, so therefore this is in meter square, and this is the volume or density, so therefore this is in meter cube. Angle of repose is normally we have taken here 30 degree. Okay, it's depend on that condition of soil. Next guys, D is equal P divided by Y into 1 minus sine theta divided by 1 plus sine theta. So when you put this value 150 divided by 18, so 150 is the allowable pressure as I discussed here from this value. Okay, so guys, when you do its calculation, so the required depth of the footing is 0.926 meter. So suppose you can say normally 1000 millimeter or 1 meter. So this is the depth of footing which is here we required for this footing 0.92 6 meters. So this is, or you can say 925 millimeter. So this is the depth of footing. So guys, this is the Rankins formula which I have discussed the front of you, how to calculate depth of footing from the given data which we discussed already. Thanks for watching. See you in next video. Goodbye.